Yes, you can start.
Okay, thank you. So IMDLIB is a Python package which is which we have developed, which me and Sashwat Nandi and I have created. So Sashwat Nandi is the original creator of this IMDLIB, and the main objective to create the IMDLIB is to generate, to download and handle the binary graded data format available from the Indian Meteorological Department. So as you know, IMD has provided the data that can be downloaded from their website. So we that requires you to just click on different. Always you have to click, if you want to download 10 different years, then you have to click each and every year and then press click on download. So this IMDLib, you do not need to provide this kind of information. You can simply provide the end year and the start year, and all other data, and all the data will be downloaded from the IMD servers. We do not host any data set. All these data sets are available at IMD servers. It's just an interface to connect, or easy interface between the Python and the IMD servers. And it heavily employs Xray, which is a Python library used for the processing of the climate data sets. So this is the two main function of IMDLib is to get the data and open the data once if you have already downloaded it. So get data will go for the download, the will download the binary file, and it will return it as a class. So here you will provide the variable type which you would like to download. So here we have rain, tmin and tmax as a value, three variables. You have to provide a start year and you have to provide the end year. If there is none in the end year, then it will only download for that a particular year. Then you can write the file name format. Default is none, which means conventions are used and they are not changed after downloading from the IMD servers. So if you provide a file name as a format as a year wise, then the file names will be named as year.grd, for example, 2018.grd. After that, you can provide, after the next argument is a file directory, where you can provide the specific directory where you would like to save your files for further processing, and the main directory should contain the variable name, the rain, tmin, and tmax. After that, you can provide the proxies, which is related to your internet configuration settings if you're behind a proxy firewall. So if you have already downloaded the data set and do not want to go again from the downloading of the data set, you can directly open the data in the form of open underscore data, where you have to provide the type, variable type, that is rain, tmin or tmax, start and end year, what's of format, and the file dir if there is any. If there is none, then that means that IMD will look for the same directory where your Python file is saved. So these are the different functions of the IMD main. These are the main important functions of the IMDLib. And for the processing part, you can get the Xray part, which I will explain you further. Then you can save your file, whatever data you have downloaded in the Python, in the form of netcdf. We have recently added the geotiff also, so some people would like to go for the geotiff format where they find it easy to process. And some people would if somebody would like to go for the CSV format, then also we have provided a CSV saving option. So you have to simply write to CSV and the file name, and it's good to go. In the future, we are planning to introduce various processing options for the climate indices. That is a coming soon feature, but we are still working on it. And let's see how it goes. So now I'm going to show you a demo that how to process, how to use IMDLib. So all the descriptions are available at all the descriptions are available for the IMDLib is available at GitHub. Yeah. imdlib.readthedocs.io. Here we will keep on updating it. A recent update is still due, so we will be updating it for the recent manual. But if you would like to, but most of the things remains the same. So here, this is the latest version. For the installation, the recommended way is to using Conda, where you can either use mini Conda or Anaconda, whatever you want. And so you can provide the Conda repository as Ansashwat and IMDLIB. You can download. This package is also available with pip, so you can always download the using pip. And if you would like to go for the development version or test out any new feature, then you can always check our GitHub library, which is hosted at Sashwat's repository. So there are several dependencies for the IMDLib, and these are generally installed when you install. These are generally available when you install IMDLib, and there is one extra dependency for the GeoTIFF, where it is called RIO Xray, that takes care for the GeoTIFF. It is optional, so if you have already installed RIO Xray, it should be then you should be able to save in the GeoTIFF format. So most once you have installed your IMDLib, then you can process. I will show you the demonstration that how you can work with this data set. So here I have created a demo file. I will be sharing this with you, and these things are already available at with me and with my website and Sasha's website, as well as the tutorials are already available. So once you have downloaded and installed the IMDLib, then you can simply uh, go for IMD import the IMDLib. So here we are using import IMDLib as IMD, short form for the IMD, and here it works. Then here in this, so once you have, so if you would like to download the data set for 8 years, then you can, we have created a variable known as start year as 2010 and end year as 2018. We are going for the variable rainfall, and we are saving the data in data is equals to, here we have imd.get data, then we have provided the variable, then the start year, then the end year, then the file format is year wise. And when we run it, so here it's downloading your various data sets. And if you would like to save, so these data sets will be saved in your file in your computer. These so if in future if you would like to refer them, so once let it gets downloaded, you can always get all those data sets from the file where you have saved, or you can provide the another file dir variable where you can separately save it. So let it download. Once we have downloaded it, so here you can see it says download successful, and here I have yes. So here you can see there, this is my demo file, and here we have got the rain, and these are the different year-wise rainfall GRD file from the IMD. So once it says download success, now we have to read it. Suppose you, so it's already in the data. So if we would like to see what in the data, we simply write data and run it. So here it says IMD core. Okay. Then you might want to see what's the shape of this data. Here you can see here it is latitude, longitude, latitude, and the time. So once you have downloaded it, suppose you already have the data and you would just only like to read it, then you can simply say year in variable, and here we have imd dot open data, and then we provide the variable start year, end year, and the file format, and here we have our data. So I'm once again running it. So it may take a couple of seconds to do that, depending on the amount of data that you want to use. Because once, so here it's there, IMD core, here we have created the data. Now, here comes the interesting part. So you can convert this data into the Xray format. So Xray data set will take care of, it's like one of the Python's most powerful libraries for the processing of the various climatological data sets. So it is compatible with all the Xray functions that you can think of. So here I will be demonstrating a few of them, and it's up to you to explore more. So here we are using ds as one of the variable and data.getXarray that will convert the data and create a new variable ds, and it will be a object for Xarray. So here you can see it is a Xarray data object where we have latitude, we have longitude, and we have time. And it is our variable name, and it is based on the convention, CF convention. So it is available for as well as we have provided with the CRS content, so that it is easier to plot and save information for the geotiff conversion, while for the geotiff conversion. And here you can see all the data files are available here with respect to time. So one of the most important, most astonishing feature of most beautiful feature of Xarray is the plotting part, where you have to just write a few lines and you can simply plot beautiful, you can get beautiful plots. So here we are providing as ds, where we are removing the non-values. So in IMD binary files, the non-values are given by minus triple line, and which creates absurd plots. So we are removing them and simply taking a mean of that particular 8 years from 2010 to 2000, from 2010 to 2018, and we are simply clicking it run, and this is our plot. So here you can see here we have latitude, longitude, and very nice plot that we can see here. So suppose if you do not, if you want to plot a time series for a particular grid. Suppose my grid is 25-degree lat and 75-degree long, and I would like to plot it. So what I'm going to do is create a new variable and select it based on the latitude and longitude, and time series is our rain, and plot it as a purple color. So here I'm done, and this is our, for the plot for the latitude 25 to longitude 75. This is the plot for the rainfall, and as you can see, this is for the June, July, and August, we can see the high peaks values for the rainfall. So these are the daily values. So once if you do, if you would like to go for a histogram thing, then you can also do that. Here we are importing matplotlib, and we are creating two plots for the time series and one for the histogram. So here we are creating histogram. So as you can see here, where there are very less values from 0 to 50, there are more values, which is expected. So this does not give you a lot of information, but it's good to it will be good for your temperature values. Histogram is better for the temperature, where you can see what is the total variation for the temperature within the within a particular within the time period. So here we are changing the aspect size. So suppose your plot is here, it's like 2 box here, then you can make it more of a you can change it in a more in a landscape form. Then here we are providing this as aspect 2 and a different size of 3. So simply by changing here, you can get a longer plot. Suppose if I want to see a number of places, if a number of places means I want a line plot for X, Y, and Z places. So here we have selected for the longitude 80, we have latitude 20, 21, and 22, and we would like to see what's the difference, what's the time series for that particular, for 3 places. So here we can simply select ds.select longitude, latitude, and then plot based on the line time. So as you can see, it has already plotted, and here they have provided a nice legend for that as well. So these are the things that you can easily do for the time series analysis. If you go for a man candle test, then you can apply the man candle test for a particular grid, or if you would like to go for a man candle test for all the grids, you can write it in a loop, and man candle and sense loop test will be done for you. So probably in future we will be adding man candle and other sense loop test as well as several other climate indices, but for the time being they are not. If you can write them, you are always welcome. So here we are plotting a 2D plots, and so here we have selected a time step of 550, which is at around 2011 0705, and we are plotting it, and you can see we have selected this time step using the I step, and then we simply plot it. And here you can see it's a very nice plot already given by the Xray. So if you do not like the color bar of that particular plot, then you can always change in the form of CMAP. So CMAP is one of the variables, and you can provide the different CMAP values for that for particular plot. So here we have provided this in the form of blue, and the next here we are providing as a title if you would like to change the title. So generally here provided it is the time, and if you would like to change this, you can provide a good title. So here you can see here it is latitude degree north. If you would like to change for the latitude degree north, then you can change it here in the form of Y label and X label. So it's up to you how much you would like to customize it. If you would like to change here, then these can also be done with simple one line statements. So if I would like to change another. So some people might ask that where do I get these values from? plt.cm.blues. So these values you can easily get from the you can simply write matplotlib color maps. So these are the different color maps that you can choose from. Uh, Here you have Idris, Plasma, Inferno, Magma, and there are several colors that you can choose from. And it's up to you which one you would like to choose. You can also give different varieties of the color. So here we are using here NiPi spectral, and next is here. So here we have incorporated NiPi spectral, and we have added one argument as robust is equals to true. So what it does, robust is equals to true, it gives you a nicer plot than the previous one. So here you can see it takes care of all the values, but here are the only the majority. Here the maximum value goes up to 140 and rest of the looks very blurry. So here what we did, we introducing robust will take care of the maximum and minimum values, and it will automatically design your color bar based on the values that we have with us, and it will give you a very beautiful plot for that. And if you would like to go for the label, suppose here we have all the colors within it, and we do not want that, we just need to provide just a specific color, then we can define it in the form of labels. So we have provided here 10 labels, so this color bar will be divided into 10 different discrete categories, and everything above that is given by brown color. So these are the things which makes it very powerful, just one line code, and we would be good to go. uh, Suppose for mean, for a seasonal mean, what is the different values for the what was the rainfall value for different seasons? So seasons are already defined in the Xray, that is DJF, JJ, and MMA, and September, October, November. So here we have provided mean as time. So here time is our daily. So these are the daily values, daily rainfall values for the daily mean value for the December, January, February. Here we have June, July, August. So June, July, August, as we know, it's our monsoon period. So here it's quite visible. So these are the things that you can easily plot within these kind of difficult plots within one line, within one line of code. So here we have divided the rainfall into group by, where we have divided it based on time based on season, and mean the time. Suppose if we do not want to go for the mean of time, if we want mean yearly, then what we can do is instead of time, we can here simply write year and then mean the time. So we have here yearly values for different uh, rainfall values for different years, and you can see it will automatically take care of the different part. As you can see here, the different latitude and longitude are not visible because it's already shared. If you would like to remove the sharing, then you can also remove the sharing, and eh, every other part will be visible for you. Suppose if you want total annual rainfall that particular, so instead of writing mean, you can simply write sum, and then once you sum, then all the values less than zero, all the values will become the background values will become zero, and we want to remove that. So here we are removing ds year, where ds year is not is equals to zero. So all the values which are not is equals to zero will be there in the plot. So it is important if we are going for such kind of methods. Sometime for the plotting purpose, we might need to remove that. And here we have incorporated robust is equals to true. So it will automatically take care of the different plotting portions. As well as here you can see this word column wrap. So column wrap means if I remove this, it will go for all way up to one line. So column wrap will reduce up to 4 columns only. So once you have, depending on how good you like your plots, it is based on that. Next we have is if we would like to take the anomaly for from the year. So suppose we have here our 8 years, 9 years from 2010 to 2018, and we would like to take the average of that year, of all the years, and then remove and check the anomaly of the rain from the mean. So what here we have done is we have created a mean of all the years, and we have removed the values from the year zero that we have done earlier, and we simply minus it, creating the anomaly and plotting it. So these are the different kind of anomalies that you can plot in your for your project. Depending on the kind of analysis that you would like to perform, these things can be easily done using the IMDLIB. So suppose if you do not want to work on Python, and you always want to work in somewhere in you would like to save these files and work in some other platforms, then there are several options that are provided. So first one is like 2CSV, where we have you can simply provide the latitude and longitude of that latitude and longitude of your study area, and then it will automatically save in the test.csv. This is just a file name. If you would like to give another file name, you can provide, and then latitude and then the longitude. So once you go for the latitude and the longitude, then it will come in the form of this test underscore latitude, then the longitude, and you can simply click it, and here you will have your date and time, and you can simply plot it even in Excel. So there won't be any difference here. So you can see that the clarity or the difference between the plotting algorithm, here you need to provide several things. For example, here you have to provide the caption, you have to provide the another title, X title and Y titles. So these things are automatically taken care by the Xray, which provides beautiful plots than the Excel. So suppose you would like to process these data sets to somewhere else where NetCDF is like the common format which people generally prefer for the modeling perspective. Other than the hydrological modeling, somewhere you might need NetCDF, then you can always, for the climatological purpose, you can always use the save the data set into data.to netcdf, and it will create test.nscdf and C. So here we have it has created test.nc, and you can open it in any of the netcdf operators. So for example, let me show you if I have here, I'm not sure. Okay. Okay, so we have in here, so let me clear, and nc dump dash header for the test.nc. So here you can see we have netcdf dimensions, time, latitude, longitude, variable, that is the rain, and mm per day rain filled with non-values, and we have these latitude and longitude values for us. And the global attributes, here we have tried to follow the conventions, the netcdf conventions, so that everybody can open it in their so that it is compatible with the other software. So conventions we have used is 1.7, which is the pretty latest one, and we have provided the crc if somebody is looking for especially for the geospatial softwares, people need crc or geospatial information for the netcdf, which we have provided here. So once we are done with that, and lastly and most interesting part, the sorry the most interesting is the geotiff conversion, where we can save your where you can save your data in the geotiff format, and let it be like test.tiff, and we have already created this test.tiff, and you can simply open it any of the uh, geospatial software. So let's see if we are able to open it in geospatial. So that's all for the IMDLIB, and if there is any suggestion or you would like to see more into the what are the other functions that we should add in the IMDLIB, so I'm open to feedback.